Hello friends, now we are seeing how Gauss's theorem can be used to find electric field due to a large number of charge. Instead of single charge, we have a large number of charge. Here, we are taking a situation is that we have a conductor of infinite length and it is uniformly charged throughout its length. A uniformly charged infinite line conductor having a charge density of lambda. Charge density means charge per unit length. Having a unit of coulombs per meter. Lambda, charge per unit length of this conductor. Our aim is to find what is electric field at a point P. Electric field at a point P. So, in order to find electric field at a point P, we are using Gauss's theorem. Remember the Gauss's theorem? Flux through any closed surface is equal to Q by epsilon 0. 1 by epsilon 0 times charge inside the surface. So to apply this Gauss's theorem, we need a Gaussian surface. So by symmetry here, we are taking a cylindrical surface as Gaussian surface. Here, this is a cylinder of length L. This is a cylinder of length L and the radius R as a Gaussian surface. For this Gaussian surface, we have three surfaces. This is the first surface, second and third. The surface 1 and 3 are what? Flat or plane surface. The surface 2 is a curved one. When you are plotting some of the electric field lines due to this charge, this is radially directed outward like this way. So, for the first surface, when you are calculating the flux for a very small area element, suppose this is a very small area element on the first surface ds1. This is the electric field vector at that point E. Angle between ds1 and E is 90 degree. When you are calculating the flux through this Gaussian surface, you have to add the flux through the first surface, flux through the second surface and a flux through the third surface. The total flux is equal to the flux through the first surface, flux through the second surface, flux through the third surface. That is, total flux phi is equal to, for the first surface, what is phi 1? Flux through the first surface. E is constant, is it? E is constant, we are taking E into, okay, or surface, you can take like this, surface integral E into ds1 into the angle between E and ds1 is what? 90 degrees. So we are writing cos 90. Okay, now see for the second surface, this is the direction of electric field. This is direction of electric field. And if you are taking a very small area element here, ds2, the angle between ds2 and E is 0. So the total flux is equal to surface integral E into ds2 into cos 0. See? What about the third surface? Third surface is again a plane surface. This is the direction of electric field. This is the direction of electric field, and this is the direction of area vector ds3. Angle between them is 90 degree. So what? The flux is equal to surface integral E into ds3 into cos 90. As cos 90 is 0, the term phi 1 and phi 3 comes to 0. See, phi 1 and phi 3 comes to 0. Now what is total flux is equal to? Total flux is equal to only surface integral E into ds2. E into ds2. Cos 0 is 1. So flux is equal to what? E is constant, is it? Equidistance from the line charge. So E is constant, E taken outside, E into surface integral ds2. What is surface integral ds2? That is the total surface area of the cylinder. What's total surface area of the cylinder? R is the radius. So 4 pi, see that? 2 pi r into L. That is flux is equal to E into 2 pi r into length, or L is the length of the cylinder and r is the radius. Now use Gauss's theorem. By Gauss's theorem, what is by Gauss's law? Flux is equal to Q by epsilon 0. Flux is equal to Q by epsilon 0. What is flux? E into 2 pi RL is equal to Q. What is Q inside this Gaussian surface? We don't know what is Q inside, but we have what is charge density, linear charge density. What is the charge on unit length of the conductor? We have a length L for the Gaussian surface. The charge inside the Gaussian surface is charge density into length. Charge on the unit length into length. So it will become Q is equal to what? Lambda into L by epsilon 0. We have to calculate what is E. What is E? E is equal to, here in this equation, it will become E equal to, take 2 pi r into L here. L and L getting cancelled. Lambda by 2 pi epsilon 0 into r. That is the electric field due to this line charged conductor. E is equal to lambda by 2 pi epsilon 0 into r. See this term? Electric field depends on its charge density and it is inversely proportional to what? Distance to the point. When a distance from the line charged conductor increases, electric field decreases. So if you are plotting a graph, it will be like this way. Electric field and distance is inversely proportional to r, like this way. It comes to 0 only at infinity.